In this problem, we're trying to estimate the maximum percentage error if we're looking to try to calculate the volume here, and we want the measurements to be 9, 8, and 5 for x, y, and z, but we're off by a little bit, and we're going to try to figure out what's the maximum error in the volume here. So that's going to be percentage. That's going to be equal to A minus E over A. So this means this is the actual value, the one that we want. That'd be 9, 8, and 5, minus the estimated thing that we get, which is going to be our small little errors that we have over here. And then we're going to subtract that by our actual value that we want over here. Again, 9 times 8 times 7, and that would be times 100. So like a quick way that you can kind of do this, if you were to do this accurately, really, is going to be percentage is equal to the actual, which was 360, minus whatever error you get. Let's say you plug in 9.1, and then 8.1, and then 5.1, and try to calculate what that would be. And you plug that into your calculator, so you get some big number over here. And then you would subtract that by 360, and multiply that by 100. So you could figure this out in that way. But we're not going to plug in these numbers directly, because we're going to want to use a calculus to figure this out. A little bit more complicated. Because, you know, it may or may not be so simple next time. So instead, we're going to want to use partial derivatives for the volume. And every time that we move the volume by a small amount, or rather what I'm trying to say is anytime that these variables move by a small amount, the volume is going to move by a small amount. It's kind of the inverse. But rather, let's say the partial v with respect to x in the x direction, plus the partial with respect to y in the y direction, plus the partial with respect to z in the z direction, is basically saying any small change in this direction and any small change in that direction or that direction is going to create some kind of change in this direction. The volume, that's the overall thing. And you can kind of think of this as the slope and this as the variable x. So this is a constant because the slope is going to be constant. In this particular case, at least, it may or may not be constant, but whatever. So let's try to figure that out. We'll say that partial of x in this equation is going to be yz. And that's our slope. Now, I said it was constant. We'll get to that in a second. But we're going to go dy. That's going to be equal to xz. And then for dz, that's going to be equal to xy. So that's what that is. And these are all slopes. Okay, so these are the slopes. This is the slope in that direction. But we don't know how far we moved in that direction until we plug in some kind of x value. So for yz is going to be 40. That's just going to be in the change in the x direction. So the slope in the x direction is 40. And for xz is going to be 45 here. So the slope in the y direction is 45. And for xy is going to be 72. So that's the slope in the dz direction. So now we can kind of rewrite this equation by saying dv is equal to 40 times x plus 45 times y plus 72 times z, right? So you can see how this is like literally it's just a slope. And then we want to know how far are we moving in these directions, right? And we're moving in this much. So that's going to be dv is 40 times 0.1 plus 45 times 0.1 plus 72 times 0.1, which is going to be equal to about 15.7 if we plug that in the calculator. So anytime that these things move plus or minus 0.1, then we know that this is going to move plus or minus 15.7. And that's obviously if they're all positive or all negative. It's not going to be mix and match there. But the idea is that this is the maximum or minimum possible shift in the volume if those were changed by that much. So that's pretty interesting. Now we'll plug this into our formula. So if we take 360 plus 15.7, we get 375.7. So if we try to plug that into our equation up there, we'll have the percentage is equal to 360 minus 375.7 is our estimated value here, divided by 360, multiply that by 100, and we should be getting, let's see, 360 minus 375.7 divided by 360 times 100 should give us about 4.36%. And that's going to be either positive or negative, doesn't really matter. But that's going to be the estimated percentage error. And keeping in mind, if we did plug in the real values, like 9.1 times 8.1 times 5.1, and try to plug that into the value, we probably would get a little bit better of an estimate, but there's multiple different ways you can estimate these percentages.